All right, so now we're going to graph a secant curve, and it's in this form: y equals a secant bx. You might think about, what does the regular secant curve look like? Well, the regular one, it's at pi over 2 and negative pi over 2. There are asymptotes. And then at 3 pi over 2, there's another asymptote. And then there's a graph starting up here at 1 going this way. It has more of a U shape. And then down at negative 1 going this way. So that's kind of a rough sketch of what a regular secant function looks like. So now we want to think about the absolute value of a to find the stretch factor, which in our case is going to be 2.5. So anytime we had a 1 or a negative 1, that's going to get multiplied by 2.5. All right. Pretend like those are straight. So 1, 2, 3. And so up here at 2.5, I know something's going to happen. And down here at 1, 2, 3, down here at negative 2.5, something's not right there, but something's going to happen. Okay, now let's talk about the period. The period's going to equal 2 pi over the absolute value of b. So in our case, 2 pi over 0.4. And that's going to get you 5 pi. You can do that on a calculator. Okay. That means the period is 5 pi. Okay. So whatever we do, we have to go 5 pi for the period. Okay. I can draw that out. I can draw from 0 to 5 pi. I don't really want to do that. I'll do it down here. But that's not really what's going to happen, because secant is an odd function. I'm sorry, secant is an even function. So it's got to be symmetric about the y-axis. So I'm thinking I can put half on the left, half on the right, and that will, work for me. Okay. In that case, then, let's think about 1, 2, 3, 4 pi. Okay? So, I'm just like trying to get it even there for the units. Now, if I'm going to put half on the left and half on the right, let me go the other way. Okay. Then at 5 halves pi, so right here, that'd be 5 over 2 pi. I'm expecting to have something happen there at the end of the period, And then at negative 5 pi over 2, I'm expecting something to happen there as well. So that would represent one complete period, okay? Now, remember, though, what this looked like when we were doing it. Okay. We could use the information we had about asymptotes. So, we haven't really done that before. But the asymptotes were at pi over 2b k, where k is an odd integer. Okay. So we know what b is, right? B was 0.4. Okay. So you get pi over, let's see, make sure I'm doing this right, 0.8. Okay, so we have this place where our asymptote is, which is fine. I don't know why this isn't moving. Okay, try moving it. Okay, it doesn't want to move. So you've got, well, now it moved. Okay. Sorry about that. I had some technical difficulties. Okay, so we're back. We have pi over 2 times 0.4. Now, it's tempting to put that just in a calculator, but you don't want to do that. You want to do it in terms of pi. Notice how I've written out the scale. I've done the x-axis in terms of pi. Okay, so think about, you can do it this way. Pi, 2 times 4/10, something like that, which is 8/10. But then you got to invert and multiply, so it's going to be 10 pi over 8. And then you could figure that out as 1.25. That you could do on a calculator. 1.25 pi. Okay, so, do the calculation, but do it in terms of pi. I guess that's what I'm trying to say. So that'll be easier for you. So now we know where an asymptote is. Okay, so this was 1 pi, right? So 1.25, okay, that's got to be a quarter of the way. So right there is going to be an asymptote. Okay, and that's one of them. And then we know there's no phase shift here. So there should be one on the other side that's going to, match up because it's an odd or it's an even function. So it's going to be like right there. And then you'd have to go another 1.25 pi. I mean, you could think about multiplying this by 3. So, well, let's just do the decimal. So 3.75 pi. That's going to be the next asymptote to the right. Okay, so here I am at 1, 2 pi was right there, 3 pi. So 3.75 is going to be about there. Okay, so that gives us some asymptotes. Okay, and now we can say, well, is, my point that's right here at 0, 2.5. Now you could think about plugging in a 0 here for x, and you'd have the secant of 0, which is 1, and then multiply that by 2.5. You could think of it that way. And so it's going to go off like this, and off like this. And you might say, well, what about more points? You could take the time to calculate more points, but I probably wouldn't. I probably would just draw it in. Okay. The other point, well, I've got to be halfway in between, right? So you could kind of look at, let's see, is there a way for me to draw without showing it? So here I was at 5 over 2, right? And so does this look like the same distance here as here? You could calculate that out, and it is. It's the same distance. So you're going to be right there at 5 over 2 pi, and we're going to put it at negative 2.5. It's going to be like right there, and it's going to be going this way. So it's kind of a long explanation. That's one period, though. One thing you have to remember with secant and cosecant, there are 2 parts, to it to make the one period. You can't just do this part and be done. So it's not like the other graphs we've had. You have to have like 3 asymptotes to do one period. Okay? So I hope that makes sense.